in the video? Did I do U?
In the second video, you did UV, but then in the first video, you did RS.
No, the first video was from a different assignment.
Oh yeah.
But in the second video, but I didn't do all of U and V. I just did some of it. So, um, let's see. I probably have it on here. Well, I won't worry about it. We'll just redo it. Okay, so you want to develop functions for U and V. And to do that, you're going to have a Carnot map with 4 variables. And you are told in the problem statement that X and Y determine which function you use, and these tables determine what your value of your function is. And I'm pretty sure that what I did in the video was function U.
No worksheets today?
What's that? No, I didn't. I did not make a worksheet. But we're just, you can just write.
Okay.
Yeah. We have control inputs I and J. So the control inputs I and J determine which function you're going to use. So this is just your Prelab. So yep, it's not, you don't have to copy this. It's just your
Okay.
Prelab. So you have I and J, and you have X and Y. And you set up a Carnot map. And make sure you get the labels correct on your Carnot map. That goes 0, 0, 0, 1, and then 1, 1, 1, 0. It swaps like that. Each column or row has to be different from the ones next to it by just 1. And the problem statement tells us that if ij equals 0, 0, then that corresponds to function g. ij, no, that corresponds to function f. ij equals 0, 1 corresponds to function g. ij equals 1, 0 corresponds to function f. And then h, and then ij equals 1, 1 doesn't correspond to any function, so that's a don't care. So you would fill in don't cares.
And how do you know that if ij equals 1 is a don't care?
Okay, that's a good question. So if you have 2 variables, then the number of possibilities you can have is 2 to the 2, or 4 possibilities. And the 4 possibilities, of course, are 0, 0, 0, 1, 1, 0, and 1, 1. When you're designing a circuit, you have to account for all of them. So even if in the program design it doesn't tell you about something, then that means the one it doesn't tell you about becomes a don't care. Yes?
Why can't you just make it all zeros?
Because it's better to make it don't cares, because that can make your circuit simpler. You could make them all zeros and you would get a circuit that works. But by making them don't cares, you might be able to get a simpler circuit. You could make them all ones. And it doesn't matter. We don't care. And so But by leaving them as don't cares, it makes it more likely that you can get something simple. Okay, now function H does not have a specification for U. And so that means when we are at 1, 0, U is don't care, because function H doesn't have a U, so those are don't cares. And when we are at function G, which is 0, 1, then V is don't cares. And then what you do is for what you have left, you fill in what your values would be in the corresponding column. So U has possibilities for function F and function G. And for function F, that's when ij equals 0, 0. So that would be this column. And function G, that's when ij is 0, 1, and that would be this column. And so then you can just read them off the map, or off the chart. You've got this column here for U, and when you've got 0, 0, that's 0. 0, 1, U is 1. 1, 1, U is 1. And 1, 0, U is don't care. And then for function G, for 0, 0, so that's this column. For 0, 0, we have 0. For 0, 1, we have 0. For 1, 0, we have 1. And for 1, 1, we have 0. Okay, so now take a quick look at function V. We already have the don't cares filled in. And for ij is 0, 0, that's function F. And when x, y are 0, so that's function F, so that's this column where ij are 0, 0. And when x, y are 0, 0, that's a 0. When x, y are 0, 1, that's a 1. When x, y are 1, 1, that's a 0. And when x, y are 1, 0, that's a don't care. And then for 1, 0, that is function H right here. So that's ij equals 1, 0. That's function H. So for 0, 0, we get 0. For 0, 1, we get 1. For 1, 0, we get 1. And for 1, 1, we get 0. Okay, so now we want to see.
I got it. I think I have
Okay.
So I circle across, so 1, do not stir, do not care 1.
That's only 3. You have to have 4.
Including the,
Oh, so this right here? Okay,
and then do the same but for the very bottom.
for the very bottom. I think I like that. I'm not sure. Let's see.
I agree with that.
Because I was going to ask.
For V.
So V would equal,
Wouldn't it be x naught,
no, that'd be J bar.
x naught and y.
Yeah, that's this row. So we don't have to, since we're not this
Oh, yeah,
this
yeah.
circle, we're not using that.
Yeah,
These circles don't mean we don't have to use I and J at all.
Okay.
Okay? So x bar y and
X, y naught.
X, Y not. Now, I'm going to pause the video here and just say that I said something about this in the other video.
Just activate.
So let's just say that we are doing a lab, and I'm recording now. We're doing a lab, and we need to figure out what chips we need. And let's say we've drawn our circuit, and we needed some knots, some 2 input ANDs. Usually need those. Some 2 input ORs. And let's throw in something fun. Let's have a 2 input exclusive OR. Okay, so now, let's go to, the website and make sure that we have all those chips. Because if we don't have them, we will have to come up with something else. So,
Have you taken every class yet?
not every class.
Dang. How many do you have left?
There's still quite a few left. You'd be surprised. There are a lot of classes out there.
You've taken most of the E ones, correct? Or no?
No, not really most of them. Taken a lot of them, but not most of them, because there's some I'm just not interested in.
Okay.
So I'm going to go to Lab Resources, and in Lab Resources, I have chips available in the lab. And the only thing you need to check, of course there are AND gates and of course there are OR gates, just make sure there's some 2 input ones, and there are. So the inverter is the NOT gate. So that's 74X04, and I think it's SL is what X is for y'all. So 74 X04 is the NOT, and the 2 input AND. Quadruple 2 input positive AND gate, 74X08. Now here's something that I should point out that we hadn't really talked about. These say positive. You sometimes might encounter some, if you don't pay attention, that are negative, and that means they work the opposite of what your truth table is. A negative means that their truth table is backwards from what you're used to.
Does that also affect like the clock timing as well, or no?
Kind of.
Okay.
It can. It does not in this instance, but it can. And then, let's see, was there an OR? That's 74X32. And then we had, let's see, I had the exclusive OR, so that's XOR. Where is that? Oh, tell me they have one. There it is. There it is. 74X86. Okay, so then I'm not going to draw, any specific circuit. I'm just going to draw a circuit. Let's say we have a circuit that has X, Y, and I, and these really are random. I'm just going to put some random things in here. This is absolutely not your function. It's just some random things. So you would draw that, and then the next thing that you have to do is identify what chips you have, which we did, and give them numbers. I'll call them 1, 2, 3, 4. And so my NOT gate is chip 1. And so everything that's a NOT gate, I'm going to write a 1 on it. So I'll put a 1 here and a 1 here. My AND gate is 2, so I'll put 2's on my AND gates. Oh, I had an exclusive OR. I'll make that my exclusive OR. My OR is number 3, and my exclusive OR is number 4. And then you have to go and look at the data sheets for these chips to find out how they're set up. And so if you look at the data sheet for the NOR gate, you'll see that it is looks like this. And all of these have pin 7 going to ground, to VCC. And the way the NOT gate, and I got it wrong I think last time, so let me make sure I get it right. So after you have downloaded the data sheets,
We have to download instruction.
That's not gonna be that hard.
you go to the data sheet and what was the inverter? Was it 4?
Yes, we're not.
Yeah. And on the data sheet I get, that's not what I wanted to do. So on the data sheet for the NOT gate, I see that I have pin 1 is 1A, pin 2 is 1Y, pin 3 is 2A, pin 4 is 2Y, and then I can look elsewhere on this data sheet and see that A's are the inputs and Y's are the outputs. So that means that for this NOT gate, I would have 1A, 1Y for that NOT gate, and 2A and 2Y for that NOT gate. This was pin 1, so I put that in parentheses. This is pin 2, I put that in parentheses. That's pin 3, and that's pin 4. So do y'all see how to do all that?
Yeah.
Okay. All right. So any other questions about the Prelab? All right. So I'll stop this, and then I can take some questions about the homework.